Good morning, students. In this section, we will discuss about the general solution of the transmission line. In our previous section, we had discussed regarding to the basic transmission line equations, and there we got these two equations, and in the derivation we got dv by dx value. This I will show it to you. One, here it is dv by dx equal to minus I into r plus j omega l, and at the same time the basic transmission line equations are final equations v equal to vf into this. These are the equations we got in our previous discussion. Now we will derive the expressions for general solution, and here let it equation number 1, and it is equation number 2, and it is equation number 3. I am considering those three equations. Now consider equation 1. Consider equation 1, that is here simply v equal to vf into e power minus gamma x plus vr into e power gamma x. That is equation number 1 I am considering. Now differentiate with respect to x on both sides. That means I am making differentiation with respect to x on both sides. So by doing differentiation for this one, here we were having, so it will become dv by dx equal to here vf is the arbitrary constant, so as usual vf into e power minus gamma x. We are making differentiation with respect to x, so the multiplicand of gamma is minus gamma will becomes here, plus as usual vr into e power gamma x. Here the multiplicand of x is gamma, so gamma. That is the point already. Now from equation 3 we have expression for dv by dx. It is the value of dv by dx. Now substitute this value of dv by dx here. By substituting this value here, then minus I into r plus j omega l equal to, in this I am taking minus gamma as a constant, common term, minus gamma into, here the rest of the terms are vf into e power minus gamma x minus vr into e power gamma x. By taking common, we are getting like that. And now the minus value on both sides will be cancelled together. Here this minus, those two will be cancelled together, and we are getting here, from this I am letting this r by j omega l to this side. I equal to gamma by r plus j omega l. I am letting this r plus j omega l, to this side, so it will becomes into denominator. Here it is multiplicand. When it crosses equal to, it will become denominator, into vf into e power minus gamma x minus vr into e power gamma x. The same value getting. In our previous discussion, we have expression for gamma, that is gamma equal to square root of r plus j omega l into g plus j omega c by as usual term r plus j omega l into the rest of the term. This term will be comes here into vf into e power minus gamma x minus vr into e power gamma x. This is the term we are getting because we have the value of gamma. This gamma is already derived in our previous section. So this, and now here in the numerator root r plus j omega l, and the denominator root r plus j omega l will be get cancelled, and finally we are having here square root of r plus j omega L is cancelled, g plus j omega c by r plus j omega L into Vf into e power minus gamma x minus Vr into e power gamma x. There is I equal to, and finally I am writing this one as 1 by z naught, 1 by z naught, that is equal to 1 by z naught into Vf into e power minus gamma x minus Vr into e power gamma x. Since from this one z naught equal to square root of r plus j omega L by g plus j omega c. Here z naught is called as characteristic impedance. The value of z naught is square root of r plus j omega L by g plus j omega c. Here z naught is called as characteristic impedance. It is also one of the secondary constants. So I am writing this equation as 4. Already I have first 3 equations, and now I am using this equation as a 4. Now I am making some substitutions for this. That is simply from the hyperbolics. I am writing here hyperbolics. From the hyperbolics we have small substitutions, that is cos h gamma x equal to e power gamma x plus e power minus gamma x by 2. Similarly sin h gamma x equal to e power gamma x minus e power minus gamma x by 2. Those are the 2 substitutions. Now I am doing here this one plus this one, that is cos h gamma x plus sin h gamma x equal to, by adding these 2, that is e power gamma x plus e power minus gamma x by 2 plus this one e power gamma x minus e power minus gamma x by 2. Here when we see those 2 terms will be cancelled together here, and we are getting e power gamma x, that's the term we are getting. Here e power minus gamma x by 2 minus gamma x by 2 get cancelled, e power gamma x by 2 plus e power gamma x by 2, we are getting e power gamma x. Similarly cos h gamma x minus sin h gamma x equal to, now I am making these 2 minuses, that is e power gamma x plus e power minus gamma x by 2 minus of e power gamma x minus e power minus gamma x by 2. Then we are getting e power gamma x, e power minus gamma x here. Like this we are getting. Now I am substituting this value and this value instead of e power gamma x and e power minus gamma x in equation number 1 and 4. That is simply here it is equation number 1. In this equation I am substituting, and at the same time instead of e power gamma x I am substituting in this equation number 4. Now I am considering, now consider equation 1. Consider equation 1. From equation 1 we have v equal to Vf into e power minus gamma x plus Vr into e power gamma x. It is equation 1. Now instead of this e power minus gamma x I am substituting this value. Instead of e power gamma x I am substituting this value. Then I am having here V equal to Vf into e power minus gamma x means this one, cos h gamma x minus sin h gamma x plus Vr into this one, e power plus gamma x is nothing but this one, cos h gamma x plus sin h gamma x. Those are the two values I am getting. Now I am multiplying internally, that is Vf into cos h gamma x, Vf into cos h gamma x minus Vf into sin h gamma x plus this one into this one, Vr into cos h gamma x plus this one into this one plus Vr into sin h gamma x. Now I am taking cos h gamma x common, cos h gamma x as a common term. By taking that, cos h gamma x terms are this one is 1, this one is 1. So from this I am getting Vf plus from this I am getting Vr. And similarly I am taking minus sin h gamma x as a common term. Sin term this one and this one, minus already taken here, Vf minus Vr, Vf minus Vr. It is equation number 5. Equation number 5. Similarly, I am doing the same process for equation 4 also. That is, now consider equation 4. That is equation 4. What we have here is I equal to 1 by z0 into Vf into e power minus gamma x minus Vr into e power gamma x. That is equation 4. In equation 4 also I am repeating the same process. I am repeating the same process for equation 4 also. Now here from equation 4, I equal to 1 by z0 into Vf into e power minus gamma x e power minus gamma x. This is the value. So that is cos h gamma x minus sin h gamma x minus Vr into cos h gamma x plus sin h gamma x. Now multiplying internally again, then I equal to 1 by z0 into Vf cos h gamma x minus Vf sin h gamma x. I am multiplying, next minus Vr into this one, Vr into cos h gamma x minus Vr into sin h gamma x. And I am taking cos and sin as a commons. 1 by z0 into cos h gamma x. Cos terms are, this is the one term and this is the another term. So Vf minus Vr minus sin h gamma x as a common term, Vf minus Vr. Here sin h gamma x into Vf minus sin h gamma x into Vf. So this one, minus into minus plus, plus sin h gamma x, sorry, here Vf plus Vr, minus into plus, minus Vr sin h gamma x. So we're getting like this. It is equation number 6. Now we have to consider a basic transmission line, a small basic transmission line as shown like this. Here let us consider a transmission line. Here is the load ZL, and now it is the input. It is the input. At the input, V equal to Vs. Source, at source V equal to Vs, and at source I equal to Is. At the same time, here at reflected voltage V equal to Vr and I equal to IR. That is simply at source and input voltage is Vs, input current is Is at source terminal, and at the load voltage is Vr and current is IR. and the total length of the transmission line is x equal to L. The length of the transmission line is x is equal to L. That means the value at this position is x equal to 0 and the value at this position is x equal to L. X equal to L. From these specifications, we are having small substitutions. That is, from this figure, at x equal to 0, that means at this point, voltage and currents are V equal to Vs and I equal to Is. Voltage and currents are V equal to Vs and I equal to Is. Now I am substituting these conditions in equation 5 and 6. That means we have already discussed equation 5 and 6 in our previous point. I will show to you here equation 5 and 6. These are equation 5 and 6. Equation 5 and 6. In these equations, in this equation 5 and in equation 6, we have to substitute those conditions. Then we are obtaining some value. Then from equation 5, first I am substituting here equation 5. From equation 5 we have, now the equation 5 is V equal to cos h gamma x into Vf plus Vr minus sin h gamma x into Vf minus Vr. That is equation 5. Now we have to substitute all these parameters, all these values in this equation. So here V will becomes, the value of V is Vs is equal to cos h gamma x value is 0 into Vf plus Vr minus sin h gamma into 0 into Vf minus Vr. Here cos 0 value is 1 and sin 0 value is 0. So 0 into this one will become 0 and 1 into this one. So Vs equal to Vf plus Vr. This is the point we are getting from this substitution. And similarly, I am letting equation number 6 also I am getting. Now consider from equation 6 we have here the equation 6 is I equal to 1 by Z0 into cos h gamma x into Vf minus Vr minus sin h gamma x into Vf plus Vr. Here again we have to substitute all these parameters. Once again we are substituting. Then I is nothing but, here the value of I is Is. Then I will be written as Is equal to 1 by Z0 into cos h gamma x, that means cos h is 0. Cos 0 is nothing but 1 into Vf minus Vr minus sin 0 into Vf plus Vr. So with this we are getting Is equal to 1 by Z0 into Vf minus Vr. And then from this we are getting Vf minus Vr equal to I am multiplying to this side Is Z0. This is the another one and this is the one. And now finally I am substituting these two conditions in equation number 5 and 6 again. That means in equation 5 I am substituting, instead of Vf plus Vr as a Vs, and instead of Vf minus Vr, Is Z0. I am substituting these two values in equation number 5 and 6. Then we will get that final solutions. When we go for the substitutions here, now substitute these values in equation 5 and 6. Equation 5 and 6 we had to substitute. Then from equation 5 again we have equation 5, we have V equal to cos h gamma x into Vf plus Vr minus sin h gamma x into Vf minus Vr. It is equation 5. In this equation 5, we have to substitute. That means in last point we got Vf plus Vr equal to Vs, and Vf minus Vr equal to Is Z0. That's I am writing here. Vf plus Vr equal to Vs and Vf minus Vr equal to Is Z0. These two values. Now I am substituting here. Finally, V equal to cos h gamma x into, instead of this Vf plus Vr, it is Vs minus sin h gamma x into, instead of this Vf minus Vr, this one Is Z0. Then it can be written as V equal to Vs cos h gamma x minus Is Z0 sin h gamma x. It is the one of the solution, general solution of the transmission line. And similarly, from equation 6 we have equation 6. Now I am writing equation 6 again. I equal to 1 by Z0 into cos h gamma x into Vf minus Vr minus sin h gamma x into Vf plus Vr. That is equation number 6. Now again I am substituting, instead of this Vf minus Vr, this one instead of this one. So with that, wording I equal to 1 by Z0 into cos h gamma x Vf minus Vr equal to Is Z0 minus sin h gamma x into Vs. So finally I am writing this one into this, then cos h gamma x into Is Z0 by Z0 minus sin h gamma x into Vs by Z0. Here Z0 will get cancelled. Then I equal to Is cos h gamma x minus Vs by Z0 sin h gamma x. It is the another solution. So finally the general solutions of transmission line are, first thing here, this one, that is V equal to Vs cos h gamma x minus Is Z0 sin h gamma x. Then I equal to Is cos h gamma x minus Vs by Z0 sin h gamma x. These are the solutions of transmission line.